Hi everyone, my name is Thomas Kim. Today is February 15, 2019. This is my 5th episode about C++ type function, modern C++ programming. In this session, we will learn C++ standard template library container class, how to tell if a template class is C++ standard template container class, how to pass container class as function parameter, how to use std reference wrapper class. This session continues from my previous video. Please click this link to visit my previous YouTube video. From this YouTube video, please download our previous source code. When download is complete, show in folder, please unzip it. And in this folder, copy the folder, copy, and paste it to your working folder. Copy the folder path. On your command prompt, right-click your command prompt properties. Show in folder, paste. Click OK. Start Visual Studio Code. In Visual Studio Code, go to File, Open Folder. Paste the folder path, enter, then select folder. Click this button. O5 Standard Container Class. Enter. Click this button, PCH H. Click once again, PCH CPP. Click this button once again, container CPP, like this. Double click this file, include talk playfun type library type util.h. Click this button, include pch h in the container, include pch h auto stream talk playfun stream auto nl stream get console out int main stream hello type function nl. Now in command prompt, dir cd o5 standard container class. Now we are compiling precompiled header pch cl at pch local pch cpp. Precompiled header should be compiled successfully. Now we are building msvc local container cpp m. Now you should see the hello type function command prompt message. If you are unfamiliar with precompiled header, Please click the link in the description section, precompiled header and response file. Double click this link. And please watch this video. In this video, I explained how to use precompiled header in C++ programming. In our previous session, type function, in this session, we created a type function CPP file. This file we created. Now we will move some libraries to include a folder. Here, we will create a header file, type function tutorial, type lib.h. If not defined, if not def, type function tutorial, type lib underscore h, define, type function tutorial, type lib underscore h, and if, end of file. Like this, we will create namespace, type function tutorial, end of namespace tft, type function tutorial. Double click this file and we will be copying some type functions from line 6. Scroll down up to this line, copy, and in this file, in this namespace, paste, then indent, like this. Okay, we will use them all. Now in this PCH header file, include PCH. In this folder, include folder, include type function tutorial, type lib. Save all. Then we close this file. We close this file. Then we close this file too. Then we close this file. In this file, standard container class PCH header file, include type function tutorial, type lib. Save all. Then click this button, right click, close others. Now we will test one function, stream template parameter count. We are testing our previous type function, type function tutorial, element type t, std, vector, int, nl, like this. Before we compile, I want to change a few more things here. Go up. I want to hide these functions. Okay, you can hide like this. Namespace hide. Okay, we are hiding all st functions, st structure up to this point, end of namespace height. Then select from here up to this point, indent like this. Then we have to prepend height like this, fix like this, and also from here namespace height. Scroll down up to here, end of namespace height. Scroll up, this point, indent, and we have to prepend height, and also here namespace height, and scroll down up to this point, end of namespace height, and don't forget height. Select this part, like this. Then in container class here, it should work. Now in command prompt, once again we have to compile precompiled header again. Now we build this is not the function. Type function tutorial. It is type count. So we have to fix like this. Okay, it works. So it gives count 2. Please note that this template class, standard template class, has 2 types. Now we create more type functions. Right click, close others, and open this file. Ctrl V. We are creating more functions here. Namespace height, end of namespace height, template, type name T, struct is container, st, semicolon here, static, const sphere, bool, value, false. This is primary, template, struct, template, type name, class, tmp, type. This is one template parameter, template parameter. Then type name, types like this. Struct is container, st. We have to provide one parameter here, primary, template requires one parameter. So we have to provide one argument like this: std vector type types like this. Static const sphere full value true. Don't forget semicolon here. Now copy once again, paste. Now we can change it deque, deque, true. Sorry, we don't need this. We don't need this line. I delete this. Also, we don't need this. Then once again, copy once again, paste, set, and map. In case of map, we need two type parameter: key type, type name, value type, like this. Then std map, key type, value type, then types. If you need more type of a template class, then you can add like this way. Here. Now we are defining a function like this: template, type name t, const sphere auto is container b, hide is container st t, value, like this. Now we are testing this type function container. Sorry, I pasted it in wrong place, like this. Stream std full alpha stream is container, I say is std vector int a container. Then we can test like this: type function tutorial is container std vector int nl. Now let's try this function. Please note that we have to recompile precompiled header because we modified the header file. Okay, is std vector a container? True. Now let's try with something else. For example, stream is std list int a container. Please note that we haven't defined about this function. Type function tutorial is container b std list int nl. Now let's try this function. False. Okay, it gives false. If you want to make it true, then you have to add like this: No. I will modify here, copy. It should be list. Then we can also use unordered map. Unordered map like this. And here we can also use multi-set. Multi-set. And multi-map. Copy. Here, multi-map. Multi-map. And unordered map, unordered multi-map. Unordered multi-map. Okay. We can test unordered multi-map. Copy. Is unordered multi-map. We have to provide two std string int. I copied and paste like this. Now let's try. Okay. Now we have to refresh our precompiled header. Okay, now everything works fine. This way now we can test whether our standard template class is container class or not. I will fix one more. I will remove unnecessary blank space. And I will add an ordered multi-set, multi-map, set, multi-set, list. We haven't added an ordered set, so I will copy, paste, unordered set and unordered multi-set. Like this I fixed, and I will fix one more. I will remove from, we are in standard container class, from PCH I will remove, cut and paste in container here. Because we are developing this file, each time we make changes to this file, we have to precompile this file again. So it's very inconvenient. So I moved in this file. Let's build once again. Precompiled header and container class. Okay, everything works fine. Now we will learn how to pass container class properly. There are two ways. There are two ways to pass container class to a function. We will learn the easy method first. The easy method is template, type name, container, cntr type. cntr means container type, void print container constant cntr type b. Then we will create a simple test function for auto constant auto e b stream e and l. Now we test this function std vector int ints 1 2 3 4 5 print container ints like this, stream and l. Now let's run. Okay, runs properly. We can remove like this. Just one more. Like this. It is displayed properly. Instead of doing this, we can modify like this too. Because the string class is defined b and l. It's easier, simpler. Okay, this way. There is another more advanced way. This is simpler way. Advanced way. Template, type name, type name, types. Here we will use template parameter, template, type name, class, cntr type. This is advanced way. Template, container type. Here, void pass template container advanced way. Then we can do like this. Constant cntr types cntr like this. Then stream cntr and l like this. Please note that this does not work. I will remove this part and I will remove this part. And I will remove this part. Let's try if it works. Okay, I will just delete this part. Let's try first. I copy and paste it here. Ints. I will disable it for the time being. Voila, it doesn't work. I will say but it does not work because this vector class actually takes two more parameters, two more template parameters. So this way does not work. The fixed way, advanced proper way to pass standard C++ container class as function argument. The proper way is this: template type name. It means one or more template parameter. Okay, at least one or more template parameter. Class cntr type. This is one template parameter. Then type name types. Okay. Void pass containers properly. Then constant cntr types cntr. We have to pass like this way: string cntr nl. This is proper way. I will copy, then paste ins. I disable this part. Now let's build. Okay, it works. This is proper way. Now I will make another function. Why this is important? I will tell you why. The proper way to reverse container elements. Template type name class cntr type name types. std auto reverse elements. I see reversed elements. Here constant cntr types cntr. Now we are using reference wrapper std vector std reference wrapper. The element type is t. Okay, type like this. Then reversed. I will just say reversed cntr. Then we are initializing cntr cr begin, cntr cr end. Then we can return reversed cntr. It will not work. Okay, it will not work. I will explain why after testing. Copy, then here paste auto reversed. B something wrong. Okay, then it does not work. Let's see. Reversed elements. Now let's try first. Let's build. Ints it doesn't work because this t is not constant. Okay, we want to remove constantness from this parameter like this, using remove constant type t std remove constant type. We actually don't need this, but I just want to show how to use this function, type function. Then we paste here constant. Okay, then it should work. Okay, it works. We haven't displayed it yet. Now, before we do this, we created another function in previous session, type function t. I think we missed one thing. Remove. No, we cannot find it. So we will create a function here, type function, template, type name t, using remove constant reference t. This is very important function. We have to remove constantness first. T std remove reference t, then t. Okay, this function is very important. I explained about this function in our previous session. So with using this, copy here, we can just say here. Okay, type, then we paste like this. We remove constant, reference and constant. Then it should work in all cases, even if this is reference type. In case in C++, reference type is not allowed, but it's a safer way. Then here we can print reversed string, reversed elements, reversed and n. Please note that this is reference. Now let's run it. What's the problem? CLS? Yes, I understand. We have to fix this issue, or we can modify like this. For auto e reversed stream e std stream. Now build and run TLS. Sorry, we have to provide get like this. Okay, it works. So elements are reversed. Okay, but I want to fix this problem. In here is coming from this string class cannot handle this case, so I will fix this issue. This is the type library. I will say operator. Okay, it's here. I will modify it like this on the fly. Copy, paste. Operator is template class, template, type name, element type, here, constant std reference wrapper element type rw reference type, then this rw get. That's it. Return. I entered this function. I modified this new type library, my own library. Then here we have to rebuild this precompiled header. Okay, we precompiled header. Now we can fix like this. Instead of doing this, here we can simply pass reversed and add. I fixed library like this, then run container. Okay, now it works pretty. Reversed. Please note that this reverse elements function has one drawback. It always returns container class of type vector. So we want to fix this issue like this. I copied and pasted here. I would say reverse element order. Then here I introduce another template class. This is a more advanced way. Copy, paste. I say return CNTR container return CNTR type and std vector. By default we use vector container, but if we provide more advanced container, then we can fix it like this. Here, instead of doing this, we can use this way, this container. Okay, then with this we can arbitrarily control the return type, containers return type like this. I will disable this. Auto reversed element order. We can now provide container type like this, ins. Now let's build. Okay, now it returns DQ type. This method, reverse element order method, this function looks perfect if default value can be assigned. Okay, now let's try. We will remove this part. I removed. Okay, then here we build with Microsoft compiler. No, it doesn't work. With the GNU compiler, it works. This is GNU compiler. It works. With the Microsoft compiler, this is Microsoft compiler, it doesn't. It says return type could not deduce template argument for return type. So this initialization does not work. Okay, so we will fix this issue. This is far advanced. I will copy this type. I say far advanced way. Now we delete this part. We modify this part like this. Type name, and we remove this part. we still preserve this as template class, but we simplify the container class type here. Then we remove like this, okay. In case of function template, this is function template. If this parameter can be deduced, then we can still initialize template parameter like this way. I say reverse elements order advanced like this. I modify like this. Then the problem becomes here. How can you know the element of this container? We can do like this, ELET. In our previous session, we implemented this function. In our previous session, we implemented element type T. We provide a CNTR type. Then if it is container, it returns element type. Okay. Then we copy this type and paste it here. Constant like this. Then the problem is resolved. I will copy this. It does not work. Then this auto reversed int. Okay, we do not provide template argument for this container type. Then default value becomes vector container type. Then let's build. Wow, it worked. Now GNU compiler. Wow, it worked. In this case, we can display type as well. Let's determine type. Stream. Type of reversed. How do we find out? We can find out the type like this. Talk, play, fun. Get type category. Reversed. And end. Then we can find out the type category of reversed. Yes, the type of reverse is vector reverse wrapper. Now try with Microsoft. Microsoft also works vector reversed container. Then we can now try another way. We can use DQ, STD, DQ, right? We passed. Now it should be DQ. See, STD DQ container class. Now with GNU, now it is DQ. So if we omit, default container will be used. If we specify, then we can determine return type like this. This is far advanced way. So I will copy this, copy X, then here I will put at the end like this and rename reverse elements order. I will name function like this. I will simplify it a little bit. It's okay. I will just leave it like this. Then here, finally, we can do like this. Type function tutorial. Reverse elements order. Like this. Then finally GNU compiler works. We need to precompile the header. We have to precompile the header like this. Then this. Okay, Microsoft compiler works. GNU compiler works. I hope you enjoyed this session. This session is a little bit advanced. I'm introducing more and more advanced concepts in this series of videos. I am targeting this series of videos to advanced C++ programmers. Please subscribe to my YouTube channel. Thank you for watching.